Okay. All right, so you learned a little bit about trigonometry, and you got your homework in. That's going to be a good grade, isn't it? It'll be a good grade? Okay, so everybody turned in their homework today. Now, what I would like to do, and I don't see you tomorrow, is I'd like to get into a couple of the realms of stoichiometry. Do you feel like you're pretty good? Do you feel like you're doing pretty well as far as the mole concept? Okay, now, so what I'm going to do is I have these papers for you. Hang on. So what I'm going to do is I'm going to have these things called certifications. Now, certification, this is called mole certification number 1. And you could call it homework if you want. But what you're going to do is you're going to do the problems that have arrows on them. So for number 1, we're going to do a couple of those in class. But right here, number 1, you're going to do B and E. And so everybody's going to get one of those. Now this is called certification number 1. And you should be able to get every one of these right. You might miss a little bit. Maybe make a little bit of mistake. Here we go. Now, if you're going to do this at home, remember, we're not doing the odd questions this chapter. I'm giving you other kind of homework assignments to take the place of it. This is called mole certification number 1, and I'd like to have this done on Thursday. Now, today's Monday. That gives you till Thursday to do it. And we're going to do a couple of them in class. I might even do, maybe I'll even do one on Wednesday or 2 of them on Wednesday. And any extras, just put them over there on that table right there. All right, so if you have a plain sheet of paper, if you have a blank sheet of paper, everybody's going to do the first one together. And it says here, do all marked problems that have an arrow on them. So let's do, I'm going to do number 1, and it's going to be 1B. 1B. So this is like a homework assignment, and let's do on Thursday. All right, here we go. 8,200 grams of iron, and that's my given, is that right? And what do they want me to convert it into? Look at the directions for number 1, moles. So change that into moles. Let's see how well you can do. Get rid of grams of iron, change it into moles of iron. Did I talk about the abbreviation for mole in here? I can't go back in time. I'm sorry. What is the abbreviation for molecule? There is none. Oh, that means I have to write out the word molecule all the time. And then, what is the abbreviation for mole? MOL. Now, somebody should stop and thought about that for a minute, okay? How long does it take me to write mole? Not very long. And what are you're going to take out one letter? And then I got to write out molecules? But anyway, if you see MOL, that does not mean molecule. You get it? It sounds dumb. But too bad. That's the way it is. Okay, so. All right, now, are you to the point where you could do the equivalents without writing them down? If not, I would suggest writing them down. 1 mole of iron equals 6.02 times 10 to the 23rd. And does everybody know what goes after Avogadro's number? Okay, if it's an element, it's atoms. And how do I get the third part? And I use 3 sig figs, so it'd be 55.8. 55.8 grams. All right. Now, some of you, especially this week, you will probably in your head, if I give you a periodic table, you probably said, hey, you know what? I'm getting good at this. I don't need to write those 3 down, but be careful. Don't miss the problem. If you don't miss it, if you don't write them down, don't miss them, okay? So in your head, maybe you said 1 mole iron equals 6.02 times 10 to the 23rd and equals 55.8 grams, without writing it down. You could. So here we go. What goes with moles? What goes with moles? Please don't say 6.02. Don't do it. Don't do it. What goes with moles? 1. What goes with grams? Oh man, there's no way. And because it's factor label, I give you credit for crossing these out, don't I? With a single line. Cross them out with a single line. Man, there's no way I'm missing this one. Now, I would like you to round all your answers to 3 sig figs and put them in scientific notation, okay? That's going to help me out when I grade it. Who thinks they have it? You already have it? As a loud voice so I can hear it.
1.47 times 10 squared.
To the what?
2.
And what's your label?
It's moles iron.
Okay, don't leave your label off. And you know what? You're done. Is everybody okay on that? Okay, now if you look at number 1E, let's try this one. And somebody help you with the first two. Wait, what's that say? Kilograms? What the heck is that? All right, what are you trying to change it into? Now, so we have a problem with this, don't we? My equivalence would be like this. 1 mole of barium equals 6.02 times 10 to the 23rd atoms of barium equals, right there, 37. And I don't mind if you use 137.3 or 137. I'm okay with that. 3 sig figs. Okay. Now, here's my problem. I don't have kilograms anywhere down here. So I can't do that what I want to do right now because it says I'm supposed to change into moles, but if you give me atoms, I can go to moles. If you give me grams, I can go to moles, but how do I go from kilograms? So you okay on that? You know that label has to go away, is that right? It has to go away. Now, it'd be nice to change it into something that would help me down here, right? What am I going to change to? What do you think, Kayla?
Grams.
Yes. And what do you know about grams and kilograms of barium that are equal to each other? They have to be equal to each other. How many grams equals how many kilograms? I'll give you a clue. The big unit always gets the smaller number, and the small unit gets the big number. That's how they're equal.
Like 1 gram.
You better not give me a big number here. He already has the big unit.
Like 0.0.
Oh, I could do that. I could do that. You could do 1 and 0.001. I could do that. That'll work. What's another way of doing it? 1 kilograms equal what? Now, I don't care. As long as that number there is 1,000 times bigger than that number there, you're going to get the right answer. Now, look what happens. Now look what happens. Oh, now I can do this, and I can change it to moles, because now I get into my equivalence, don't I? So what do you think? And again, I'm looking for your work and your answer. I'm looking for your work and your answer. Somebody else, somebody new. Tyler, you got this already calculated?
I had 4.12.
Say it again.
4.12
4.12 times 10 to the first. Is everybody else getting that or not? Oh, you got the first 2 problems done in your homework. How about that? Okay, there we go. If you want to be nice, you can circle the answer so I can find it real easily. But all right, what do you think? Yes.
We testing this week. Do we have a test on this week?
No. Right now I have a quiz planned for Wednesday. Now I looked on the calendar, and you guys have a math test that day, and you have another test. So you have, I think, 2 tests and 1 quiz, the most you can have. Is that right? Is that the most you can have? I believe that I'm not going to set you up for failure, but it's probably one of the easier quizzes I've given because it's all about the mole concept. You get it? And on the back, there are 3 factor label problems. And so my quiz is pretty straightforward. It's about the mole concept. And here's one of the hardest questions on there. Say something like this. Let's see. which one has more atoms in it? 1 mole of helium or 1 mole of uranium? Which one has more atoms in it? 1 mole of helium or 1 mole of uranium? Who has more atoms? Neither. They both have 6.02 times 10 to the 23rd. Isn't that right? Yes? Okay. Which one has more mass? 1 mole of helium or 1 mole of uranium? Uranium. And then the factor labor problems are just like you've been doing. And so I don't see this as being difficult. And I think you do pretty well on it, really. Okay, good question. So no, our test would be, since you're not here on Friday, okay, what I have to do is either we start the second certification on Thursday, probably not. We'll probably start certification part 2 on Monday, and I usually give you a day and a half for that. So Monday and Wednesday would be certification, and certification part 2 is it's like I give you a packet, you sit here, you want to use your notes, you can, you just can't talk to anybody, and you just answer the questions. I come around, if you get them right, I put my initials on there and say, oh yeah, I'm certified there, I know how to do that problem. And then they're kind of like the problems you would do on a test. And then so the test would not be till next week, probably Thursday. I think we're looking Thursday next week. So a week from Thursday. That's a long time. Okay. All right. Well, is everybody okay on that? I would like you to work on this. This is part 1, certification part 1, and that has everything to do with factor label and equivalence. And if you're really good at that, you could just put that in your pocket and say, I am good at that part of the mole concept. All right. Well, let me go to another problem here. Okay. So the next thing we're going to do, even though I'm going to talk about the mole an awful lot in these 2 chapters and 3 chapters, there is a section here of stoichiometry that has nothing to do with the mole. And so I'm going to do that now, and then I'll get back in the mole in just a minute. So this one's called How to Find Things Percent Composition. Now, I think your book says this. I think your book calls it mass percent. And I call it percent composition by mass. There's no real difference there. But what you do is, let's talk about this. H2O. What percent of this by mass is hydrogen? What percent is oxygen? So what do you think? So what I have to do is I'm going to take you on a little trip. Remember I talked about the little world and the big world? So we're going to start in the little world, and we're going to find out what happened here. Let's pretend that I can go visit the little world. Whoop, the little world. Let's say I'm going to visit the little world, and I shrink myself down. Remember the magic school bus? I don't have that, but if we could shrink ourselves down and go visit the world, the little world, and I would take with me special balance measures, little things like that, and it would be like this, and I would find out that how many hydrogen atoms would be in that water molecule. How many? There'd be 2, right? So 1 atom of hydrogen would weigh how much? How much would 1 atom weigh? And I know I haven't seen you since last week, but remember I told you most people don't know that this decimal number stands for 2 things? So how much does 1 atom of hydrogen weigh? 1 AMU. Okay. Now, there's another atom of hydrogen there. I'm looking at you. Have put him on the balance. Hey, you weigh 1 AMU. Okay. And 1 atom of oxygen, and that's 16 AMUs total. Okay. I forgot a little story I was going to tell you. Anybody here play baseball? Don't you play baseball? Okay. Okay, and you might, maybe everybody else, you probably get this right and they won't, okay? So let's say you have a doubleheader. You have a doubleheader, and in the doubleheader baseball game, you have 3 singles and 1 fly out and 1 strikeout, okay? Everybody see that? Yes? Okay, now, what I want to know is these are called hits and these are not hits, okay? So you had 3 hits and 2 not hits. To find his batting average for the day, would you say 3 divided by 2, or would it be 2 divided by 3? Now, everybody's going to vote. Everybody's got to vote, okay? So you had to put your hand up. How many people think to find his batting average, it would be 3 divided by 2? Raise your hand. How many people say it's 2 divided by 3? All right, who didn't raise their hand? Why not? Right, because the actual answer was not given to you. Because I want to tell you something about this. Whenever you want to enter the world of percent, remember this always, divide by the total. I never told you that. What was the total number of times at bat? 5. To find your batting average, he had 3 good things out of 5, and that would be 0.60, right? 600, that's a good. So one more time, why did I trick you? Because I want you to remember, percent, you always divide by the total. Got that? Now, I want to find what percent is hydrogen. All right? How many AMUs were hydrogen? Look over here. How many AMUs are hydrogen? 2 AMUs divided by, what's the total? What's the total? 18 AMUs. Okay, this cancels out. What do we get here? Decimals. Point what? Which is about 11.1%. Is that right? Okay. Now, what's the percent oxygen? That would be 16 AMUs. 16 of the 18. Oh, I see. And what is that? 89.9? Is that what that is? Is that 0.8999? 889? 88999? Okay, or about 89? Is it 89%? 88.9? 89.9, isn't it? Wait, is it 0.89? Wait.
When you put 16 divided by 18 into the calculator, you get 0.8888.
Oh, 0.888. So 88.9. How about that? Can I say that? All right, there you go. Now, so what's interesting is in the little world of one water molecule, what is the percent by mass of hydrogen? It's about 11.1%. Really? You mean most of the mass of one water molecule is in the oxygen? Yeah, that's right. Well, now, I'm going to let that symbol not represent one molecule. What else can H2O stand for? What if I'm not in a little world? What does H2O stand for if I'm not in a little world? It's a 4-letter word, starts with M. No, not molecule. Mole. 1 mole of water. Okay. Now, if I give you 1 mole of water, how much does it weigh? And you say to yourself, let's see, 1 mole of water equals 6.02 times 10 to the 23rd molecules of water equals What's the molar mass of water?
Grams.
How much?
18
18 what?
grams.
18 grams. Grams. Okay, let's do percent by mass. Here we go. What's the percent by mass of water? And that is 1 gram of water plus 1 gram, 1 gram of hydrogen, 1 gram of hydrogen, 16 grams of oxygen, 18 grams total. And what is the percent by mass of a mole of water? Let's see, 2 grams over 18 grams. Wait a minute. You're trying to teach me some kind of lesson? Is that right? And what's the percent by mass of oxygen? 16 grams out of the 18 grams. 0.888 equals. Wow. Wait a minute. Okay, so what's the lesson there? What's the lesson there? What is the percent by mass hydrogen of 1 water molecule? What's the percent by mass of hydrogen in 1 water molecule? 11.1%. What is the percent by mass in a mole of water? That's a lot. What percent by mass is hydrogen? 11.1%. You understand what I'm saying here? If I'm in the world of mass, I can just do these percent things, can't I? And I don't care how much you give me. Once you give me 25.333 moles of water, what percent of that is hydrogen? Look at me, look at my face. What percent of any amount of water is hydrogen? 11.1%. Oh. So if we go to the moon and we find water, let's say we find water on the moon, and I want to get oxygen out of there. Can I calculate how much oxygen I can get out of that water? What if I said I had 3.5 tons of water? What percent of that would be oxygen? About 89% of it. Yes? So percent composition, I'd say most people understand that pretty well. Percent by mass composition. Yes, no? Let's do a real quick problem. 40 grams of water has how many grams of hydrogen atoms in it? Let's do that. 40 grams of water equals how many grams of hydrogen atom are in there? Did you ever watch the movie called The Martian? That was pretty good, wasn't it? I kind of like that one. How many people saw The Martian? Oh, only 2 of you? Okay. Remember what he was doing to keep himself alive? Remember how he had to make himself like a house, and he had to grow things on the Martian soil? And he had to have water, didn't he? And then he also had to have heat. He had to have some heat because it was cold there. And so he had a chemical reaction going on that was producing hydrogen gas. And he calculated how much hydrogen gas, and then he was then he knew that if he could burn this much per second, it would give him heat and it wouldn't cause an explosion. But then I shouldn't give this away. If you want to watch the movie, it's a really good movie, but something happens and he miscalculates something, okay? I won't say anything else. Anyway, they're doing this kind of stuff right now, you know. Hey, if we go to the moon and there's a rock that has this on it, what if it has aluminum oxide in it? What percent by mass is oxygen? So if I had a ton of that kind of rock, how much oxygen could I get out of that rock?
Mr. Phoebe?
Yes, hello. Yes, Hi. Okay, Maddie, do you know you're going? Okay, sorry, Madeline. Okay, so anyway, what's the answer here? Did you do this? Any amount of water is what percent hydrogen? Is that what you did? So when you multiply by percent, use the decimal, don't you? Is that right? What do you got for the answer?
4.44.
So anyway, out of 40 grams of water, if I wanted to get the hydrogen atoms out of there, I've got about 4.4 grams, 4.44 grams of hydrogen atoms in there. All right. What do you think? I don't think percent composition is that difficult, but it's the one part on here that is not based on the mole. But most kids understand it because if they know to divide by the total, you can get percent. I'm gonna do one. Let's go ahead and do this one right here. And if you can tell me what percent of aluminum oxide is aluminum and what percent is oxygen, then we're gonna move on, okay? So let's try it. What percent by mass of aluminum oxide is aluminum? What is the percent by mass of aluminum oxide, and what's the percent by mass of oxygen? And see if you can do that. You already done? Okay. You're getting pretty fast at molar masses, aren't you? Did you do molar mass? Because you divide by the total. Okay. I remember that you always divide by the total, so what you need is a molar mass of aluminum oxide, is that right? All right, Noah Wood, what do you have for the molar mass of aluminum oxide? 2 of these and 3 of those, what do you have? Because you can't do the problem without it. Do you have it? Okay, you don't have it? Okay. So over here on this side. Elizabeth, do you have the molar mass of aluminum oxide?
I have 102.
How much? 103?
Put them together.
103?
102.
What?
102.
10 what?
2.
2. How many people got 102?
I have 101.8.
Oh, that's fine. That's fine. So everybody have about 102 or 101.8? Everybody okay on that? All right, so we know we're going to divide by that. And, okay, what do you have for the mass of aluminum, Elizabeth?
54.
Okay, I like that. So what's your percent?
52.9%.
One more time.
52.9.
Okay, what about your oxygen? Is that 48?
Yes.
And what's your percent?
47.1.
Now, can I give you a little clue? Everybody look up here. When you do a percent composition problem, when you add these two numbers up, if it doesn't come close to 1 or 100%, if you change it to percent, it's okay to be 99.9, even 100.1. But when you add them up, if you only get like 96%, you've made a mistake, haven't you? Now right here, she had 53.9 and 47.1. Does that add up to around 100? The chances are she did it right. You get that? What do you think? All right, here we go. Here's your big problem. Here we go. 1,000 grams of aluminum oxide contains how many grams of aluminum? I'm gonna make some aluminum cans. Yeah, I think I'm gonna make some aluminum cans. Where?
Beside the A.
Oh, AL2, sorry. Oh, wait, AL203. Okay, I'm gonna give you 1,000 grams of Al2O3. How many grams of aluminum are in there? What? What? How am I supposed to know that? Okay, as soon as you get the answer, look at someone sitting next to you, and if they said, yeah, I'm done, show them what you got on the calculator, show each other what you got on the calculator, or on paper, either one. Are you guys, if you're not matching, talk about it. If you're not matching, talk a little bit. Now, was Elizabeth right when she said 53.9? Is that right?
I said 52.9.
What?
I said 52.9.
53.9?
52.
Multiply 52 times that.
Oh, see, I had them all. I found the total.
52.9. Oh, that's even better. That's even better.
Yeah.
Okay.
That's what I got.
All right, so here we go. 1,000 grams, and I don't care how much aluminum oxide you have, a speck of it or a planet, a solid planet, how much? It's 52.9% aluminum. There you go. So 0.529, whatever you get there, I bet you're going to get 529, aren't you? Is that right? I have to know 1,000 times. Okay, so if you got, how many of you got 529 grams of aluminum? About like that, something like that. Raise your hand. All right, if you didn't get that, tell me what happened.
I just didn't really know how to do the problem.
Okay, and as I know that in the book they show you how to do it, and you say, I better remember how to do it, but let's think about it for a minute. Any amount of aluminum oxide is what percent aluminum? About 52.9, right? So that big lump of aluminum oxide, it's 52.9% aluminum. And whenever you multiply by percent, you have to change it back to the decimal, don't you? Okay, so I just took 1,000 grams times 0.529. That's how I got it. What do you think? Is that pretty easy? So that part of stoichiometry is the next part. We had the mole concept. We spent a lot of time with that. Factor label. And then we did percent composition, which we really didn't even mention the word mole in here, did we? Whenever you're doing percent by mass, you're in the mass world. But then there'll be times when you have to get in the mole world. All right. Now, let's see. Oh, I know what I can ask you. You got one more thing. We'll be done here. Okay, last one. On your book, on page 218, at the bottom, you have a sample problem. And that's why I want you to read the book, because the book has these sample problems. You could get a piece of paper out, try it, and they have the answer on the next page. You get that? So let's take a look down here. It says ethanol. Ethanol is an alcohol. Whenever you see a thing that ends in OL, it means it's an alcohol. Ethanol, methanol, see that? Anyway, ethanol is C2H6, C2H6O. Yeah, there we go. Now, they want to know what is the percent by mass of each element, and eventually on the test, I want you to be able to do it without having to write all this stuff down. You get that? So why don't let's do it real fast. How fast can you, without looking, how fast can you, and I wouldn't do it like the way they did it. All right, how fast can you tell me what percent by mass is carbon? What percent is hydrogen? What percent is oxygen? All right, let's try it. You have about 2 minutes. If you can do this in 2 minutes, I think you've mastered this. What percent by mass in ethanol is C2H6O? What percent is carbon? What percent is hydrogen? What percent is oxygen? About 30 seconds. Just tell yourself, I can do this. I can find the mass percent of every element in ethanol. Remember, you have to divide by the total, don't you? You always divide by the total. The total mass. We're in the world of mass, so I need the mass total. All right, since we're running out of time, I'll give you the answers up here, and you can also look in the book. It says, the author says that you should have gotten somewhere around 52 or 52.1% carbon. Is that what you're getting? The author says you should get around 13.13% hydrogen, or something like that. And the author says you should get about 34.7% oxygen. Wow, if you did well, if you did that way in less than 2 minutes, I think you pretty much mastered that. All right. Well, thank you very much. You did a great job. You did a great job today.